Here's pre-calc. It's your lecture part 2 for 3.1.3. And it's wanting us to solve this system of nonlinear equations. And so, as with any system of equations, you can use substitution, elimination, equal values, all those kinds of methods for solving the system. This one, I realized that the top equation is a circle and the bottom equation is a parabola. So I'm going to prepare myself for the possibility that I might have more than, one solution. I could have 2 or 3 or 4 solutions. I could have up to 4 solutions. So I'm just going to keep that in my mind as I solve. So I think most people would look at this and say, hey, it's already solved. It's kind of already like this y is all by itself, right? So maybe you'd want to plug in x squared minus 14 up here. And I started doing that because that seems like the kind of obvious way to go. But then I wrote yup, because when I square that, I'm going to get x to the 4th, and then I'll have like minus 28 x squared plus whatever 14 squared is. I'm just kind of going to have a mess. And this doesn't seem as easy. I thought of something easier. And the thing that I thought of was this x squared right here. It's kind of almost by itself. All I'd have to do is add 14 to both sides. And then I'd have x squared equals y plus 14, and I can plug the x squared in, or the y plus 14 in right there. So that's what I ended up doing. So I decided to go with solving this for x squared, and then plugging y plus 14 in for x squared. Don't look at that part over there yet. That's later. So we're right here. So this was x squared, but now it is, I substituted y plus 14 plus y squared equals 34. Okay, and then I'm just going to try to move things around until I can get it to look like a quadratic. So I took the 34 to the other side, combined like terms, and I got a nice quadratic. I needed something that multiplied to make negative 20 and added to make 1, so it was 5 and negative 4. So I got these two solutions. I got y is negative 5 and y is 4. So I want to find the x's, because these are just 2 points on the graph somewhere. I need to find the x's that go with them. So I stuck my negative 5 and my 4. Where did I stick them? I stuck them right here. And then I said, well, I want to know what x goes with negative 5. So I went up here and I plugged in for y negative 5 equals x squared minus 14. Add 14 to both sides. And I messed up at first, but that's 9. So x squared is 9. So when I take the square root of both sides, I'm going to get plus or minus 3. Oh man, why did I write it like that? Plus or minus 3. That's what x equals. So what that means is that when y is negative 5, I get plus 3 and minus 3. So that, at first I thought that was silly, but now I see I probably have 4 solutions. So I'm going to make another ordered pair for my negative 5. So that way I can put the plus 3 in, and then I can put the minus 3. So these are just 2 points on the graph where the two equations, where the two functions, well actually that's not a function, where the two equations intersect. So now I'm going to do the same thing for the 4. I'll put 4 in for y. So I'll rewrite it down here. So I'm going to say 4 equals x squared minus 14. And then I can add 14 to both sides. Well, I guess that's 18. So when I square root, I'm going to have x is equal to plus or minus the square root of 18, but I think I can kind of simplify that root a little bit, because I know 9 times 2 is 18, so I think on scratch paper over here I'm going to go square root 9 times 2. That's square root 9 times square root 2. That's 3 root 2. So I have x equals plus or minus 3 root 2. So that means when I plugged in the 4, I got x is 3 root 2, but I also have x is negative 3 root 2. So I'm going to need another ordered pair for 4. So I'm going to have 3 root 2 and negative 3 root 2. I hope that made sense. There's 4 points of intersection, because this was a circle and that one's a parabola. And I think that's about it.